Okay, here's our last rule, rule number 6. Okay, again, this is our last rule because even though there are 7 rules, we have covered rule 7 already earlier on. This is called the quotient rule. Rule number 6, differentiation rule for lesson 3.3, rule number 6. You don't have to actually memorize the rule number, but it's you should know the name for this rule. It's called the quotient rule as opposed to the product rule that we saw on the previous previous video. At a point where x is not equal to 0, the quotient y is equal to u over v of two differentiable functions u and v is differentiable and is defined to be this. Okay, the derivative of u over v, with u and v being expressions on their own, the derivative of that could be v itself multiplied by the derivative of u minus u times the derivative of v divided by v squared. And informally speaking again, okay, so this is your formal notation. Okay, I guess it's an intermediate notation. It's not too formal, but at the same time, it's not too informal. Informally speaking, you could do this. Okay, the derivative of u over v could be written as u prime v minus uv prime divided by v squared. Okay, that usually helps me to differentiate any kind of quotient expressions, quotient functions. Okay, so take a look at example 5 as an example. Okay, so you have x to the third power minus 1, which you could consider to be u. And then you have v as x squared plus x plus 1. And then, okay, just like the product rule, I want to start with finding what u prime and v prime are on its own. U prime would be 3x squared, and v prime would be, it appears to be 2x plus 1. And then now I'm applying the quotient rule to find the derivative of this entire quotient, the entire rational function. Okay, so what would that be? So f prime of x, okay, formally speaking, would be u prime. So that would be du dx, or 3x squared in this case, times the v, which is x squared plus x plus 1, minus, not plus, unlike the product rule, minus uv prime. So that will be x to the third power minus 1 times 2x plus 1 all over v squared, which is x squared plus x plus 1, and then that trinomial squared. Okay, and when you simplify this, this becomes 3x to the fourth power, I should say, fourth power plus 3x to the third power plus 3x squared minus whatever the answer for the product of the last two factors are. That would be, I need more space for that. Okay, so let's see what that would be. So that would be x to the 2x to the fourth power, multiplying these two and then multiplying these two, you get x to the, it's a strange order, okay, x to the third power. Multiplying these two, you get negative 2x, and then multiplying these two, you get negative 1. But those terms are all inside of a parentheses, and then this is all over x to the second power plus x plus 1 square. And if you simplify this, if you were to simplify this, you got 3x to the fourth power minus 2x to the fourth power, which ends up as x to the fourth power. You have 3x to the third power minus x to the third power, which gives you positive 2x to the third power. You have 3x squared, which is by itself, so plus 3x squared. And then you have negative of negative 2x, that becomes plus 2x. And then you have negative of negative 1, which becomes plus 1. Okay, so it's 1, 2, 3, 2, 1. And then on the bottom, you have x squared plus x plus 1 squared. And believe it or not, if you do expand that one, if you square the trinomial on the bottom, you get the exact same thing, x to the fourth power plus 2x to the third power plus 3x squared plus 2x plus 1. You could try it if you have time. And then in the end, as a result, your final answer becomes 1. So by using the quotient rule, you get the answer of 1. You get the derivative of 1 for this whole thing. There could have been an alternate method. Okay, I'll show you an alternate method for this one. Okay, it's not possible for every question, but for this one, the fact that I could factor out the top and the fact that that simplifies with bottom, you could have done this differently too. X to the third power minus 1, you have a difference of cubes. X to the third power is a perfect cube, 1 is a perfect cube, and you have a nice factoring pattern for that. You could factor x to the third power minus 1 as x minus 1 times x squared plus x plus 1. Okay, again, if you need to review that, the words to search or look up difference of cubes, and then it automatically implies that you're trying to factor that. And then you see that you could factor, okay, so after you factor x to the third power minus 1, notice that you could cancel out the part, one of the factors with the entire denominator, and you could rewrite the fact that f of x is pretty much equivalent to x minus 1. Okay. So now, let's see what's going to happen here. Okay. So now f of x equals x minus 1. What is the derivative of that then? F prime of x would just be 1, as we have for this entire process. Okay, so you could verify your answer in that manner. Again, okay, I made this problem to be intentionally doable, okay, with using the alternate method, but not all questions are doable using the alternate method, so you do have to know what the quotient rule is.